Hello and welcome to our webinar, Wire Harness Design Automation Basics 2. My name is Hans-Peter Bleer. I'm Senior Pre-Sales Engineer for E3.Series at Zuken. Here is the agenda for our webinar today. Before we will start, you will get a short review of the last webinar, Wire Harness Design Automation Basics 1. Then we will focus on the physical part of the design process. In addition to my slides, I will also show you a solution demo. And at the end, we will do a short summary. In the last webinar, Wire Harness Design Automation Basics 1, we have seen the logical part of the design process. We started with the wiring diagram, using symbols and components, do the connections, assign signals, cables, conductors, cores, and single wires. Intelligent components will take care for connection materials and also for mating parts. Crimp parts were selected automatically by the connected wire. We have seen how to handle complex cables, conductors, cores, and single wires with a lot of attributes in the logical structure, such as shielded and twisted wires. We have reused information from a PCB layout to speed up the design, and we have seen how electrical checks will increase the quality of the design at an early stage. We also talked about topology design as a part of the logical design process. We import a 2D graphic, define installation spaces, place components and define a routing path, get information about cables, conductors, cores, and single wires in the segments, and also information about wire lengths, weight, and cost will help to evaluate and compare different concepts. Now let's go on with the harness design process. When the logical design is done, we can transfer all related information to the 3D MCUT for the routing of the harness in the original 3D environment. With the data from the 3D harness, we generate a scaled 2D drawing. Customers without 3D MCUT can use data directly from the wiring diagram or topology as well to design the scaled 2D drawing. The cabling board will be used as a nail board for the production of the harness. In addition, appropriate lists for production and service are required. 3D routing, the cabling board, and the documents for manufacturing and service are part of the physical design process. Now let's look on the design flow. From the wiring diagram or the topology design, we transfer the data to the 3D MCUT system to do the routing of the harness there in the original 3D environment. This part of the process we cover with the E3D routing bridge. Now I will give you a short solution demo about the export to this routing bridge. Here we have a video, and in this project we have a wiring diagram which contains 3 harnesses. This is harness number 1, harness number 2, and also harness number 3. In harness number 3, we select 2 connection lines, and then we start the routing bridge with the add-ons menu. In the Export tab, you can see the available interfaces to MCUT systems. We can show all cables and wires from the wiring diagram, or we only show cables and wires we have selected in the wiring diagram. Selected cables and wires in the routing bridge are highlighted in the wiring diagram, as you can see. There is a setup with some specific settings and values for the export. The export will create a XML file for the 3D MCAD system in the defined path. In the wiring diagram or in the topology design, we export the related information with the E3D routing bridge and import them into the 3D MCAD system. There are interfaces to many 3D MCAD systems available, for example to CATIA, SolidWorks, PTC Creo or ProEngineer, Inventor, Siemens NX, Solid Edge, and IDEAS. Typically, the routing module will route the cables, conductors, cores, and single wires, takes care for collision checks, checks the bend radius, and calculates the length. When the routing in the 3D environment is finished, we have to convert the harness to a scaled 2D drawing. To create a cabling board, we use the 3D design data and create a scaled 2D drawing. Therefore, we use E3 formboard. Here we can see the process in detail. When the routing of the harness in the 3D environment is completed, we use the harness export function to export the 3D harness into an XML file. With the flattening tool, we convert the 3D harness into a 2D geometry. Importing the 2D geometry with the harness import generates a formboard automatically. Formboard and wiring diagram are connected by the objects directly. That means if you make a modification here in the formboard, it's already done here in the wiring diagram. And also if you make a modification here, this will be done here also. It's also possible to do modifications and use the same loop again, export this to the 3D MCAD system. And later on, if you do some modifications here, you can use the export function and the flattening, and then there is an update function to update an already existing formboard. Now a short solution demo about this harness export, flattening, and harness import to create a formboard. Here we see a picture of the routed harness in 3D MCAD, for example CATIA, and you can also see protection material and fixing parts. The 3D harness and its additional parts will be exported into XML file in the harness export format. To convert the 3D harness into a scale 2D drawing, we start the flattening tools in the add-ons menu. Here you will see the XYZ axis. And now we import the 3D harness, rotate him a little bit, and next we have to define the backbone. After the flattening, the backbone will be shown in a straight line with all the other branches. We can define the backbone by selecting two line ends or automatically. You will see now the 2D harness, and we will export him as XML file for the harness import into formboard. Next, we will start the E3D routing bridge with the harness import to create a formboard sheet. We select the 2D XML file, import him, and then we create a formboard sheet. And after the import was done, we have a 1:1 scaled formboard drawing, which can be used as a cabling board. Here you will see the connector with additional protection cap. The corrugated tube to protect the harness was also imported from the 3D MCAD. And after moving and rotating the T connectors, the harness drawings is complete. At the end, you can add some measurements for the production. A lot of harness manufacturers will not use a 3D MCAD system, and therefore I will show you some more possible workflows to create a form board. If there is a logical design in E3.Series available, we can use the design data directly from the wiring diagram or topology design. If we have no data from E3.Series, we can import a bill of material and a connection list from Excel. When we only have a PDF file or wiring diagram on a paper, we also can create a form board directly from scratch. Here we see an example using data directly from the wiring diagram or topology design. Now let's see a solution demo how this will work. The wiring diagram defines the connectors, the cables and wires, and their connection logic. Here in the device tree, you will see a cable with cores or conductors and also wires, and you see the targets from the wire ends. Here we have the connectors, and now we create a new sheet. We create a form board sheet, and the next what we are doing is we select all the connectors and place them one by one on the form board sheet. Additional to the connectors, we can place a table symbol which shows the connected wires and the signals and also the target of the wire. Blue dashed lines show the connection logic from the wiring diagram. This will help to connect the segments of the harness later on. Now we do the connections, and you will see the logic line, they will disappear. Next, we adjust the angle of this branch, so 45 degrees. And now we check the diameter of the segment, so we know which Y distributor we have to use. Next, we select the Y distributor in the database, move him with drag and drop on our drawing, mirror it on the X-axis, and we do the same with this T distributor. And next, we want to adjust the segment lengths. So we select segments and we define a manufacturing length. And at the end, we adjust the segment lengths to the manufacturing lengths. So 150 millimeters, adjust them. And you see it's shown with a blue line instead of the red dashed line. This means the manufacturing length and the displayed length is different in the moment. So we adjust these segments also. We have to move the table symbol and adjust the last segment also. Now we select the corrugated tube and assign this corrugated tube to the segments of our harness. So this one, and we place it on the segment 1, 2, and 3. And we do the same with the other segments. Now we need some fixing parts, so we select some cable ties, some clips, and you will see they will rotate it to the angle of the segment automatically. And if this is done, the form board is complete and we have all information for the manufacturing. And when we are creating a bill of material, you can see this will not only contain the connectors and their grim parts, it also contains the protection material like corrugated tubes, T-distributor, Y-distributor, and so on. So we have the complete information for the manufacturing now. Here we see an example creating a form board with Excel files from other systems. Loading a bill of material and a connection list from Excel, import them into E3.Series, and create a form board with the imported data. Let's see how this will work. We have an empty project, and with the add-ons menu, we start the import. First, let's have a look at this Excel file. And you will see there's a bill of material which contains the component type and name and higher level assignment, location and device ID. Here we have the cable and wires. Here some single wires with a destination from and to. And we have the same with the cable, which has some cores or conductors. And here is also a target from and a target to. And this information now we want to import into E3.Series. So we start the import. It's done. And let's have a look at the device view. And here you can see all the wires, all the cables, and the targets of the cores and conductors or the single wires. And we also have imported the connectors. And now we create a form board sheet, like we did it before. Select the connectors, place them, and so on. Now it's the same way we did it before, so we can skip the video after a while. And when we place the second connector, you will get the connector information and also the logic line, and so it's the same like you have seen before. Let's go on. Here now you will see how to create a form board from scratch. We have a drawing on a paper or as a PDF file, and with this information we place table symbols for the connectors, assign wires and cables, and then also create a form board with this information. Let's see how this works. We have an empty project and an empty device table. So we go to the component database, select the used connectors, and move them with drag and drop into our device table one by one. They will get a device ID automatically. And now when we have the connectors, we also add a cable already at this time. So we select the cable and add this cable also. And you will see this has 4 conductors or cores. And now we are creating a normal page, a normal sheet, and then we place table symbols for each connector. This symbol shows the pin number and later on shows the assigned wire and the signal. And so we have a table symbol now for each connector. And then the next step, when all the table symbols are placed, will be to assign the cables, their cores or conductors, and also some single wires. So let's assign the cores and conductors one by one, from here to here, one from here to here, and the next from here to here, and the last one. And now we select the single wire, AWG18 wire, for example, and we assign the single wires from here to here, from here to here. And so in this way, we are defining the connection logic in a very easy way. And when this is done, we create a new sheet. We create a formboard sheet. And now it's exactly the same we did before with the imported data from Excel or with the data from the wiring diagram. That means we select the connectors. We have the wires with their target. That means the connection logic. Now we place the connectors on the form board, and it's exactly the same you have seen before. So let's skip this video and let's go on. When the form board is ready, we have to prepare additional information for the manufacturing. This will be the next step in the design flow. Let's see what we need for manufacturing, documentation and service. The one-to-one scaled cabling board will be done with E3 form board. All components, cables, wires, protection materials, fixing parts and additional parts are included in E3 form board, so we can create a complete bill of material. For each cable, core or conductor or single wire, E3 form board knows the detailed lengths, even with the rest lengths inside the connector's housing. With this information, a cutting list can be created very easy. Additional views of the harness are available for service documents. Interfaces to manufacturing systems makes it easy to work with pre-manufactured cables and wires to save time and money. During the whole process, we have changes and modifications. Therefore, we need a powerful revision management to handle revisions and new versions. It's not only to make a new version or a revision of a project, it's more to recognize and document the modifications and differences in the documents. Let's repeat the whole process again, starting with the function, designing a wiring diagram, getting a rough overview about the harness topology, transferring the data to mechanical cut and do the routing there in the original 3D environment, designing a cabling board with the 3D data, creating documents and data for manufacturing and service. So we covered the logical part of the design process and also the physical part of the design process. Now let's talk about the webinar takeaways. For complex harnesses, there is an urgent need for automation. If a 3D MCAD tool is available, this should be used to do the routing of the harness in the original 3D environment. There are different possibilities to create a cabling board, import the 3D harness from the mechanical cut if available, or use data from wiring diagram or topology, or use Excel files or create the cabling board from scratch. To produce a harness additional to the one-to-one scaled cabling board, you also need a bill of material and a cutting list. If you have machines to pre-manufacture cables and wires, you need interfaces to transfer the data to those machines. Additional to the documents for the manufacturing, special documents for the service are requested. We have seen how to cover the whole process from design up to manufacturing. If you have any questions, please let us know and contact Suken under Thank you for attending our webinar. Bye and see you next time.